Hey guys, welcome back. Welcome back to my channel. We are going to talk about residuals, linear regression, and how to interpret linear model. So give me a minute while I keep grabbing stuff, right? All right. Oops, that thing is not clear. I'm gonna have to zoom it. Hold on guys, I'm trying to zoom the camera so you guys can see the board and not the actual teacher. Because that's our area of interest. Oh, that is horrible. How do I get my phone to not look so foggy, guys? I did. But it's still... Hold on guys, give me 1 minute. Background work here. Can you see me? Alright. So here we go guys. So residuals. This is basically the left off, or you say the runoff after your model made prediction. So the residual always plot the x-axis against the residual plot always shows the x-axis against the residuals, and there is a concept behind this where you determine if a model is appropriate or not. So when you're trying to determine the appropriateness of a model, you always check the residual plot. And the model we're talking about is when you draw your straight line graph. It's not touching. Let's change the color. When you draw your straight line graph, either using technology or your hands or pen and paper. Oh my God. All right. All right, so as I was saying, when you draw your graph, for example, the ones in the black at the top here, you will realize that it can be a linear graph or an exponential graph / nonlinear. Once you see a curve in your data, you know that your graph is no longer a linear graph, all right? And so, for example, this one here would assume to be linear as it has a straight enough condition. This one here will assume to be nonlinear as there's a curve in your scatter. So if I should draw a straight line through those points, or a line of best fit, it's not going to be perfect, but I'm going to try my best to cover it. Oh, that's horrible. So that's my line of best fit for that one. And for this one, that's my line of best fit. So with this, I can tell you if the model made an accurate prediction or the model went below when I check its residual. So a residual is an example of what you see here in the red. So if there is a curve in your data, meaning, for the example one, here, if you see a curve in your data where it's trending upwards, going down and making a pattern, you know that your linear model is no longer appropriate because a pattern exists. And for your linear model to be appropriate, you should see random scatters about your residual. So if I should ask you how to tell if a model is appropriate or not, you basically say you're going to check the residual and to see if a curve exists or not. So like this one, we will say the linear model is not appropriate, and the linear model is in the form y equal a plus bx or mx plus b. However, your teacher uses, just use that one. So this will say the linear model is not appropriate. And the reason for this is to say because a curve exists. Alright, and the curve you're talking about is the one you're seeing here. For this second graph, we'll say the linear model is appropriate. And the reason behind this, and the reason behind this is because you see random scatter, because the plots S are randomly distributed and you see random scatter. How you talk is basically how you write, but ensure you just say that it's random and a curve is right there. Randomly distributed. Alright, so the next question you could be asked is, what is the sum of any residual? And this here is a given. In previous classes I've shown you guys how to, on the live stream I've shown you how to do your graph and how to show the residual plot. So you will know that the sum of all residual, and that's the letter E, is equal to 0. So when you add up all of those residual values, your sum should give you 0 at the end. If you don't get 0, something is wrong. Because basically telling you what is left off after your model make its prediction. I'm going to show you an example of what I'm talking about. So if you, this is too small. If you have your graph right here, and you have a line of best fit, there are going to be times when you have the model the line going through some dots, or there are going to be times when the line doesn't touch any of the dots. You can either go above it or below it. In this case, this is where we check to see if the model made accurate prediction or if it went below. So this point here could be like a 2-2, but the model predicted it to be somewhere like a 2-5. So the model overestimated this point because the point is below the model. So the model basically overestimated that one. And it overestimated by like a 3. So the 3 here would be your residual. Alright? For example, this one here could be maybe a 3-8 for this point right here. Or maybe a 5. Let's say put this with a 4-8. This point here could be like a 4-8. But the model underestimated it and it called it like a 4-6. Alright, so this one the model made a short prediction, or you say underestimate it by making it smaller. And so whatever that is left off after you subtract 6 from 8 is going to be considered your residual. And a formula we use to find the residual is the actual value minus the predicted value. Alright, so like for example, this one, the actual value was 8 for the y, so it's y minus y hat, and that's E. So the actual value for this one was 8, but the model, 8, but the model predicted it to be 6. And so the predicted thingy you see here, the predicted number, is 6, and that's basically what the model assumed it to be. And so the residual in this one would be 2. And so the difference between this point and the line is like 2 places. Let's examine the one here. So the actual value is the one in red. So the actual value here is 2. So E is equal to y minus y hat. So the actual value here is 2. But the model predicted it to be 5. And so to find the residual, you basically put in what you have here. And so 2 minus 5 is a negative 3. And so you basically say the model overestimated this one. Alright? And that's how you calculate the residual of your data values. I hope this part you understand it. So residual formula, actual minus predicted value. You basically plug the numbers in your calculator or in the formula and you solve. Do you have a question? Of the 2? Yeah. Of the 2? Do you have a question? No. Alright. Alright, so here we are finding residuals and we're finding the observed value. So given that the actual value is 36 and the predicted value is 20, what is the residual? So we need to know the residual formula. So residual is denoted by the letter E, and that's equal to y minus y hat. And here they say the actual, so the actual is always y, the predicted is the y hat. So the actual here is 36 and the predicted is 20, so the residual will be 36 minus 20, which is 16. So the residual there is 16, and that's basically it. They didn't actually explain anything, so we don't have to go any further. This one now says find the observed value if the residual is -5 and the predicted value is 15. Again, you go for the residual formula and put in what they give you. So they give you the residual to be -5. So -5 comes here, and that's equal to observed, we don't know, rewrite that. Predicted value is 15. We're going to subtract 15. And right here, we're going to solve for y. My throat is hurting. I need to get some water. Put a mask on for what? What's wrong with me? To drink water? You want to see me die? I haven't got no water. That's old. I can't drink that. Okay. So we have to solve for y in this case. And to solve for y, you basically add 15 to both sides. So that cancels. So y is equal to 10. Oops. So y is equal to 10. Come on, stop. Alright, let's make it a plus sign because it's not erasing. Y is equal to 10, and that is our observed value. So whatever you're given, you always write your residual formula and you just input these values in it and solve for the missing variable. Do you have any question?
No.
No. Okay, good. This one, you're given the equation of the line in the form y equal mx plus b, right here. And m is given as 1.56 and b is given as -0.42. You're asked to write equation of the line. What would you do?
About the things.
So equation is y is equal to, okay, it's gonna be m. The value of m is 1.56. So you see m, you put 1.565. The variable, you rewrite it because it's independent. And the b value is -0.42. So you're gonna have -0.42. And there we go for the equation of our line in the form y equal mx plus b. Pretty simple, would say. All right. So let's move on to the other one. This one says you're calculating the linear regression equation. I should have put that right there. Equation. So you're given critical points for your linear regression equation. But before we do that, I'm going to explain a simple concept here. So when it comes down to the regression equation, there are two things that we pay attention to. We pay attention to the slope and we pay attention to the y-intercept. And remember, for the regression equation, we pay attention to the equation in the form y hat is equal to a plus bx. Alright, the same thing as your mx plus b, just that your regression needs you to pay attention to different letters, which is a and b instead of m and b. Alright, so similar to the y equal mx plus b, you need to find your slope. And you normally use the slope says that y2 minus y1 over x2 minus x1. You only can use this when you're given 2 points and you want to find the slope of your line. Alright? But because we don't have 2 points, we have what's called the correlation coefficient. We have the standard deviation of y, standard deviation of x. We have the mean of y, the slope, and the mean of x. So these are the two formulas that we have to use when you're finding the regression equation in the form y equal a plus bx. Alright, so since as we are CP statistics students, we don't need to calculate these values for ourselves, even though we can do it because we know how to find the standard deviation of numbers. Remember that formula? Remember this formula? Standard, okay. So if you were in AP class, you'd have to use this to find all of your stuff each time. But because we're CP, they will give this to us and we just basically put it into the formula. They'll give it to us looking something like this. So we need to know what is the equation, what is the formula for the slope, and what's the formula for the intercept. So I'm going to put it right here. So B is equal to RSY over SX. So to find the value of B, which is your slope, you need to put in these values into the equation to find B. So let's go. So B is equal to R. R is negative 0.2, so negative 0.2, parentheses, because these two are multiplying. SY is 6 over SX, which is 4. Alright? Using your calculator, you're going to do the top part first, and then you divide it by 4, as we have to apply 0.2. We found our slope. Next, it's time for us to find our y-intercept. And for the y-intercept, we use the formula A is equal to y bar minus b of x bar. Alright, so we need to know what is y bar, what is x bar, and what is b. So y bar is right here, the mean of y, and that's 18, minus the slope that we just found here, which is our negative 0.3 times x bar, which is up here, over 30. So once you are able to write all the critical points in the equation, you now go to your calculator and put in these values and find it. If you want to, you can always simplify this part, as in it will be plus. But if you want to, just put in the calculator at the same time, and it should give you the same answer. Just want to know this thing is not pausing. So what is 18 plus 0.3 times 30? 27? So A is equal to 27. So for our equation, I'm going to put it right here. Let's see if you can change the color to something you can see. So we're going to say y is equal to A, 27, plus, in this case, negative 0.3, x. And that's the equation is y hat. And that's the equation of the regression line in the form y equal AB 3x. I'm going to say AB 3x. Y is equal to A plus BX. I just told you guys exponential, but my bad, I think my brain is going too fast. Alright, let's move on to the other one where you're asked to find some missing variable given the equation of the line. So some teacher will give you these critical points in table forms and some will just write it like this, but the concept remains the same. Once you can identify them, you just plug them into the formula and find your answer. Alright, this one says given the equation y equal negative 10 plus 15x, you're given the standard deviation of x to be 0.8, mean of y is 50, standard deviation of y is equal to 15. You need to find x bar and r. So given that we have two formulas that we pay attention to, this is one formula and this is the other, you have to check if it's a slope formula or the intercept formula that you need to find whatever is missing. So if you're talking about x bar, between these two, only the intercept one has x bar in it. So we have to use this one to find x bar. Thinking about r, only this one, the slope formula, has r in it, so we have to use that one. So we are going to do that. So let's find x bar first. So x bar, so A is equal to y bar minus b of x bar. So we need to know what is a, we need to know what is b, we need to know what is x bar. But from the equation given up here, I can tell you that this is a, and I know that this is b, because they gave it to us already. Alright? So let's put in what we know. So negative 10 is equal to, y bar is 50, minus b, which is 15, x bar, which we don't know. So we can just rewrite it like that. Alright, when you're solving, you basically do the algebra term here. Making people know how to do algebra. I'm going to go through this. So it's a positive 50. So minus 50 from both sides. That cancels, bring the negative 15x down. X bar down. That gives a negative 60. We want to find, what's this called? X bar. So we have to divide both sides by negative 15. So that cancels, so x bar is equal to 4. And that's how we solve a question that looks like that. And therefore x bar is equal to 4. So I'm going to erase this question mark here and just put 4. Since as I worked this part already, I'm going to erase some of these stuff so I can have some space to write. Now we want to find R. So to find R, we have to use the slope formula. So we need to know what is B, what is that. So let me write it back. So B, or maybe not. Let me just erase this part. So let's find R. So B is equal to R sy over Sx. So B is 15. So 15 is equal to R, we don't know it. Sy is 15. R times 15 over Sx, which is 0.8. And once you're here, it's basically you completing it using algebra, where you solve for R. So we're going to multiply by 0.8 on both sides because it's divided by 0.8. So multiply by 0.8 on both sides, so that cancels. So 0.8 times 15 is some number that I don't know. 12, that's equal to R 15 or 15R. Let's put the number first. 15R. So from here, all we have to do is to divide by 15 on both sides, since as they are multiplying. So divide 15 here, divide 15 here. That cancels. R is equal to, I know this number, 15. So that's 3. So it's 4 over 5, that's 80%, 0.8? Okay. So it's going to be 0.8. So R is equal to 0.8. And that's how you find a missing variable. So you always pay attention to the two formulas given. The B slope, the slope formula, and the y-intercept formula. Any question? No? Alright. Alright. I just explained that one to you. So the final one is for us to interpret the linear model. So the linear model is basically the equation, or the predicted equation. So y hat, that's not writing again. Oh my god, these markers are playing with me. Alright, let's change it. Y hat is equal to a plus bx. So we have to know what is a, what is b. So again, a is your y-intercept and b represents your slope. But when it comes on to interpreting it, it'll tell me when the slope value is affected by the x value, or the independent variable, what happens to y? So we know we use some terms to describe the relationship right here. So we use the word per. So per every movement of the x value, y is affected. We use the words like for every. You remember these words? Okay. So for every, let's say for each and for every. So we use these terms to describe the relationship between the slope and the independent variable. So the question here says cost of Uber is equal to $16.99 plus 1.50 M, where cost is given in dollars and M is the total miles driven. So you're asked to interpret the slope and the intercept. Let me put the word right here. So you're asked to interpret the slope and the intercept in context. So first, you need to tell me what the intercept is. So a word used to describe the intercept is the initial value, I want to say the starting point. You can use any of these terms because they both mean the same thing. So let's go. And remember, context is very important. So whenever you talk, tell me what you're talking about. So the initial cost of a Uber, should I say Uber drive? Okay, initial cost of an Uber is, right here is your A value, so it's going to be $16.99. What happened to the price after this? Okay, so you're going to say the cost then increases by $1.50. Did I put money sign here? Money sign. By $1.50 for every miles driven. Or you can say per each mile or per mile or for every mile or however you speak, you're right. And that's perfectly fine because you don't always be taught the same. But once the concept is the same, that's what we're looking for. And that's how you interpret the equation. The next question is asking you to tell how much would be the total cost of a ride 8 miles long. So if you want to travel 8 miles with this Uber driver, what would be the total cost? So we're going to put cost hat, I almost read the word hat, is equal to $16.99 plus 1.50 times here, M is miles, and they're saying that you're traveling a total of 8 miles. So where you see M, you're going to put 8. Because you're basically evaluating at this point. Trying to figure out how much money you're going to spend at the end of the day. So $16.99 plus 1.5 times 8 turn out to be what? Project? $28.99. So it's $28.99 for the total cost of the drive if you travel 8 miles with that person. And that's basically how you analyze, analyze, it's okay. How you interpret the linear model, how you determine which equation to use when finding the slope and the intercept. Where is the other one? How you find them using the algebra aspect of your prerequisite. What's this one? How you find the residual using the given formula. And how you tell the sum of the residual and if the model is appropriate or not. Do you have any question for me? No? Okay. So once you understand this concept that was taught and revisited, you should be able to do very well. Just know the concept because the numbers will be different, but the same concept is going to be there. Alright. Okay guys, this is the end of our live stream. I hope you guys understood what I explained, and if you have any requests, feel free to leave them. I'll be happy to help you. And I'll see you on my next video or another live stream in the future. Have a good day.